Assess 19, page 287, the AQA question. I'm told there OAB is a triangle, there it is, OAB triangle, and P is the midpoint of OA, there it is, carefully positioned. I mean, you can tell that OP is vector A and PA is vector A, so it's right in the middle, same direction, same magnitude, and there it is. Now, AO and, P is the midpoint of AO, yeah, got it, and M is the midpoint of AB, yeah, very straightforward there. And then I'm told that OP is A, PA, etc, etc. Right, so basically they've just described what's in the diagram, and P and M are midpoints, so let's just get on with it. And OB is worth 2 B's as it goes. Right, write down an expression for AB in terms of A and B. Right, so from A to B in that direction, let's, I can't really put arrows on this, there's too much going on. So what I will do is do that, and call that A and B, and there I go. Don't want to know what A, B is. Well, how do you go from A to B? You come from A to O, and then O to B. So A to B can be accessed by going AO followed by OB. Very, very easy. Let's try and squeeze it in here. A to O is going to be minus 2 A's, and O to B is plus 2 B's. If you want to make it look pretty, it's 2B minus 2A. Alright? Positive value first, or the positive vector first. Both equally correct. Now, Q lies on AB, that's the line AB, such that AQ is a quarter of the entire line AB. Oh, fair enough then. So, alright, show that PQ is going to be half A plus half a B. Alright then, so essentially I've got AB, which is the value I've just got here, and I want to quarter that thing, don't I? So let's just try and play around. Now, I want to work out PQ. Let's do it here, I'll run out of space. So PQ is accessed by going from P to Q, that way. Yeah, I want to go from P to A, then A to Q. That's it. So from P to A, and then I will go from A to Q. And I know I've got it right, starting at P, finishing at Q, which is what we want, isn't it? So P to A is called vector ABA, and A to Q is a quarter of, I'm told, a quarter of A to B. Now, A to B, I've just worked it out here, a quarter of 2B minus 2A. Again, got to tidy up a little bit. A plus, well, a quarter of 2B's is basically half a B, and a quarter of minus 2A is minus half an A. Check it. Half, 2 lots of a quarter is a half, but it's negative. So what have I got here? I've got A minus half an A, which is a positive half A, and I've got my positive half B weighting there. I can factorise it just to make it look very, very pretty, and I get all my marks for that. You can stop at that stage if you want to, or factorise, but if you're not sure about factorising and you don't want to be too flash in the exam, leave it as it is, because it's not about factorising, it's about getting vectors right. So we've basically proved that's correct anyway. I didn't need to factorise it, as you can see, because I arrived at half A plus half B, and that's what they wanted. Explain your answer. Well, there's nothing to explain. I've actually proved it by showing the vector diagram that I'm using, PQ. How did I do it? I went PA plus AQ, substituted the vectors and done it. Should explain your answer. I have explained it. C. Let's hope I get the question to fit here. Write down and simplify an expression for O to M. Oh, all right then. O to M. So to go from O to M, I must go from O to A. I think one way of doing it anyway. O to A, and then go from A to M. Yeah, O to M. All right. Easy. I could have gone, of course, up here and then up there, but never mind. O to A is going to be 2 lots of A's, plus, now, A to M is going to be half the size of vector A to B, because I'm told M is the midpoint. So I'm going to use this again, plus half of A to M, which is, half of A to B, which is that one, half of 2B minus 2A. Well, that's going to give me 2A plus, well, half of 2B's is a single B, and a half of minus 2A's is a single negative A. Simplifying, 2A minus A is A, B is on its own. There it is. That's absolutely beautiful. I think I'll write it in just in case I need it. So that's going to be A plus B in that direction. Right, let's see if I can do D and make it fit here. I hope I can. If not, it's a fresh page. Right, it says here, explain why the answers for B and C show that OPQM is a trapezium. Oh, does it now? B is half AB. Let's just write it in there. So that's half A plus B. Oh, there it is. I've done it. It's simple. Explain why the answers for B, and B is this half A plus B thing, and I really did factorize it this time, so I can see that A plus B in that direction is completely parallel to the, half A plus B in that direction from P to Q is exactly parallel to vector A plus B running from O to M. If they're parallel, then I've got one set of parallel lines, and therefore that's a trapezium. Okay, let's try and write this here. Hope I can make it fit without my picture getting in the way of it. Right, so I'm going to say PQ equals half of A plus B, and OM equals A plus B. Therefore, OM, or mate, it's PQ, yeah. OM is a multiple of PQ, it's twice as big, in other words, times 2, therefore parallel with OM. Is that alright? OM is a multiple of PQ, it's twice as big, and therefore it's parallel with, so what's the subject of this question? OM is a multiple of PQ, therefore OM is parallel, therefore it is parallel with PQ. So I know what I'm trying to say. So parallel with PQ. So that's a trapezium. Let's read it through. PQ is half an A plus B. OM is a complete A plus B. So OM is a multiple of PQ in terms of times 2. So the scalar is times 2, is twice as big. Therefore, OM is parallel with PQ. Thank you. That's it. End of vectors, and I'll catch you in chapter 20. Vectors are quite easy in places, but once you start getting to fractions and then the arrows start flipping around the other way, it becomes a right pain. That's it. That's A star. I think it's A star for a reason. It can get really painful in places. End of it. Done.